Live streaming is on.
In this video, I'll show you how to set up and manage live streams in YouTube's live control room. We've built a brand new stream workflow in live.
Hello?
Hey, HEMAL.
There's a lot of static coming from your end. I'm not sure why.
Okay, let me try.
Your voice comes clear, but when you're not speaking, it's too much of static.
How about now? You're muted.
Yeah, it's almost the same, but maybe my volume was a bit high.
Okay, how about now?
Yeah, better.
Okay, I think those are the fans.
Okay.
All right, I had a favor to ask. Can you lead this today, by any chance?
Can I what?
Can you lead this meetup today? Take charge of it.
Sure.
The reason
Okay.
is,
Yeah.
been working at the asylum last couple of days making those face shields, and I ended up with a migraine today. So
Oh.
I'm going to be here. I'll try and do the KiCad, whatever stuff. But
Okay.
basically, every time I speak, my head kind of really bangs.
Oh, I see. Oh man.
Let me put
So
on
sorry
my
to hear that.
video. Sorry, that was covered up. So yeah, it's.
Yeah.
I mean, once I get this, usually if I take the medication before it starts, it stops right then and there. But once it starts,
Okay.
it stays around for at least
Yeah.
2 days. So
Oh man.
I took a nap in the afternoon, but that didn't help.
Let's see. Okay.
So if you were to talk about the library management part also, I am happy if you want to do that. Essentially, it's just
Uh,
I wanted to show how you can, like take an existing global library, copy a part from it, save it to your local library, and use that instance to put parts on your board or rather on your
mm,
schematic. Because then
okay.
when you share it with anyone else, it's like self-contained, right? There are no broken libraries or missing libraries and stuff like that. So that
I
was
get
the
your point.
yeah.
But the problem is I'm running 4.0, so
Okay, okay. I'll
yeah.
take care of that. Sure.
Okay.
Take.
Uh,
I am hoping the YouTube live part works because it seems there's 4 people waiting over there, and
okay.
I I think it is.
The YouTube.
Okay, I'll post the YouTube stream on the Jitsi Meet chat, which should be here. That's the live stream. Oh no, that's my dashboard. That's
Oh yeah.
yeah, live. Copy video URL. I hope nobody can hack into my account. I hope. Okay, so that's the stream. Is there a way to delete a message? Also, you can't delete messages. All right, we already have a
Yeah.
couple of people joining us, so I hope they identify themselves. So it just says hello, Gister.
Okay.
And by default, I
I
made
see
sure
the
they
live is working.
okay, works. Cool.
Yeah.
All right, so that's there. Now let's see. The trouble is going to be uh,
Size breaker.
sharing the KiCad program windows because they are different programs. So PCB new is different from schema and pro. So when you do screen share over here, you can share one window but not the whole of KiCad.
Oh.
So
Oh.
yeah, it's a
Okay.
problem with KiCad really because it happens with no matter any video tool you use with Zoom, with Jitsi, with
Uh, can you share like the whole screen? Like, so
you
I'm gonna
can. But
try
then
to share my.
for a couple of seconds you'll see like those the infinity mirror kind of display. So let me see. Here was here's my screen.
Uh,
So I can share my entire screen like so. You probably get infinity screen. Someone's sharing.
so I'm sharing the whole of it right now.
Okay.
Um, because if yeah, I think.
Yeah.
But then if I go back to the meeting, then it will be like a mirror.
Yeah. But I
Yeah.
think we will live with it. So let me see if I can. So here it is. Here's the infinity mirror effect, and then I can
Yeah.
start
Hmm.
KiCad normally, and you should see that come up
Okay.
like so. And then I can start schematic. That should come up. And then I can share PCB, and hopefully that should come. That's PCB. Might as well just add the 3D view here for what it's worth. So that's 3D view. So that's the all of the windows. But when I come back to Jitsi,
So
this is
for
what
any questions or something, yeah, yeah, I see.
then I can stop.
So what we can do is I'll keep the chat window open, and if there are any questions, I'll prompt you,
Yeah, please
and
do.
I can do the same when I'm presenting or something like that.
Yep, yep, that works. We can team up on this.
Yeah.
Uh,
Yep.
all right, people
That's
looking around, say hello. Papa POSCHLR. I have no idea how to pronounce that. And fellow Gister.
um, where do you see? Okay, I see. Yeah.
Yeah, toggle tile views that you
Okay.
can see.
Drew is here. Okay.
There's Drew. Why has Drew got two windows? I think he's doing phone and computer, I guess. There's a couple of fellow Gisters around. Uh, okay, so I'm hoping everyone is hearing this. If you want to talk, just use the raise hand command and then unmute your mic. And everyone else can mute theirs. That probably helps the flow. All right, so we are at 5:30 and time to get this rolling. Welcome everyone. Who's around? Want to just say a round of highs, everyone?
Hi Anul, Shree. Hi Anul, Shree from Bangalore.
Hey Shri, Drew waved out, so hi Drew.
Hi Anul.
Hey, okay, give me a second. I need to switch on some services over here. Hey man, you can just say the highs while I'm back in a minute.
Hey
Hey
everybody,
everyone.
Shree from Bangalore here. Uh,
Hi
thanks for the
Shri.
session. Yeah.
Yeah. Okay. So Anul is gonna talk about schematic library management, and after that's done, I'll be showing on how we can generate footprints from step models. So I believe everyone's here. So I think Anul, you want to take it away?
Yeah, hey everyone, thanks for joining in. So last week we did this and it was kind of pretty much unstructured. We just kind of rambled about different things in KiCad and FreeCAD, and we learned a few things, but there really wasn't any structure to this meetup. So this week we decided to add two topics that we can kind of show how it works. And at the same time, then we can take up any questions that anyone has on problems they're facing or how to do certain stuff, and we'll try and answer those. So if everyone's okay with that, that's how we're going to do it. The the one thing that I've noticed with a lot of KiCad projects that are shared, uh, let's say as open source projects, is broken libraries. And quite often this happens when you're using a global library that is installed on your system, but the person who is looking at your project may or may not have that same library, or may have a different version of the library, which is even worse. So you could end up with a broken schematic, or worse, a broken PCB. So I've been using KiCad since 2009, and over the years I've developed a system which may not be perfect, but works perfectly well for me. So I thought I'll just show off how I do that in terms of managing a project when I start up. So there's a couple of things you do to set up things before you even get started. And I thought it'll be nice to do that. The other thing I'd like to talk about is good practices with respect to sharing your project. So let's say someone is interested in your project and wants to take a look, but they don't have KiCad handy. Maybe they're looking at it on a phone, for example. In such cases, how do you make sure that your project can still be accessed by people on the phone? So what I usually do is try to add a PDF of everything that I'm doing in a PDF folder. So schematics and all the technical layers. Okay, YouTube has not started. Let's see. Says waiting for Anool Mahidharia. Damn. Okay, I'm going to add the other live stream URL, which is this. Copy and can people try this link? And I'm going to post it in the YouTube. Everyone try this. And if someone can confirm that it works.
Yeah, it's working for me.
Okay, works for him. Can someone else just click that link and see if it works on YouTube Live? See if it works on YouTube Live. Okay, works for Drew. So, okay, so, and I posted the link on the old YouTube Live stream comments box. So hopefully whoever is there can move over to the new one. All right. Let's say 7 waiting. I wish there was a way to tell them to move. All right. Well, I'm new to this YouTube Live, so sorry if I'm not up to speed on how to do that. Maybe the stream key changed because I set it up in advance and I started this now. I don't know. That could be an issue. But anyway, let's get started with the organization part of what do you do when you start off a KiCad project. Let me just get one of the latest ones that I was trying. Yeah, okay. And then let me share my screen. So it goes share the entire screen. So here's another issue with KiCad because it's actually a bunch of separate programs bundled together. eSchema is separate from PCB New, is separate from 3D Viewer. It's not easy with video tools like Zoom or Jitsi to share an application window because there isn't really one application window for KiCad. You have separate windows and it's not easy to share it. So you have to end up doing the entire screen share, and it's a workaround. It works, but not really the best way to do that. So that's my screen, and you see the infinity mirror. Then let me. So here's a typical folder setup that I use for KiCad projects. Of course, the main folder contains all of the KiCad files, the KiCad PCB, the netlist, the project file, schematic, backups, and so on. But it's important to notice the folders that are being used. There is one that says .pretty. So this is where the PCB footprints would be put, all the KiCad mod files, modules. So I like having, and this is a local library which is used with my project, and the project doesn't use any external global libraries at all. And that's what I'm going to be talking about how to put stuff here so that you can use it because it becomes easy to share. And then there's also a libs folder where I store the symbol library, or the symbols that are used in the schematic. So these are the two folders you set up as important. The third one I like to do is have a set of renders like this, so people can get a view of what the PCB is going to look like in 3D view, even if they don't have KiCad to do the 3D view, for example. So I put a couple of renders over here to, and the one that I haven't added here, but I can do now is a folder called PDF, where I shove in all the PDFs, the schematic, all the sheets of the schematic, and the technical layers of the PCB. So front and back copper, front and back mask, and front and back silk. At least these 6 pages, and the edge cuts. That's important. I also always add a PDF for the drawings layer where I put dimensions of the PCB. That's kind of handy when you're trying to do your CAD work, making an enclosure or whatever. To have the major dimensions of your board printed out very clearly. What's the mounting hole dimensions, the spacing between holes, the size of the PCB and stuff like that, all the critical dimensions. So that's the folder structure that you set up before you get started with a project. And then once you are done with that, you can, let me see. Easy doing this. So you start your project and then get your schematic started. And we're going to make a new library over here that is local to this particular project. And how to do it. It's already an existing project, but I can mess around with it. It's not an issue. Let's say I want to add a couple of maybe resistors and LEDs as indicators. So I click on the insert symbol tool. It brings up all the symbol libraries. So the ones you see here are all global libraries. So let me just check for R, that's the resistor. And we can see that it's coming from the device library. Okay. So we say, okay, just put it here. And if you look at the properties of this, you can notice that the library reference is device colon R. So it's from the library called device and a part called R. But this is a global library. So if someone wants to look at your project and doesn't have the device library, then they are going to get a broken schematic. So we're trying to avoid that over here. So the easiest way to do this is right click on this and go to properties and open this up in library editor, edit with library editor. That brings up your library editor, and you can see that the symbol R is listed under the devices library. It's a long one, library. Lots of parts, device. So what I want to do now is there's down here. I want to right click this and say export symbol, right? And I'll have to shut off Hackaday chat, but I'll get to that later. And it's going to ask me location where I want to do it. So let me go to the project I'm working on, FreeCAD, libraries, and give it a new name. Okay, give me a minute. Let me shut off Hackaday chat, guys. Kind of messing up things over here for me. Okay, there goes. And I can now give it a name. By default, KiCad tries to give it the name of the component that you've already chosen. So in this case, r.lib, but I can just call it as specs test.lib and save it as a project library, not a global library. That's important. And say add. Once you do that, it's added to that FlexLab library, but it's not yet available over here because you haven't. Here it is, flex test R. Okay. The last step of this process is to now close the symbol editor, and in your eSchema, select preferences, manage symbol libraries. Go to your project specific libraries, and wow, this is new. This was a manual step, and I'm glad KiCad has upped the game. So it's already added here as a local library, which is fantastic. I used to have to do this step manually earlier. So that's great. So you already have this library available from for your project. If I click on it now, I can just change the place from where it is being picked up as instead of device, I can say flex test R, and that's it. So that's one symbol added to a new library which is local to your project. And uh, if the global symbol now changes, let's say for some reason they decide to increase the length of the pins, uh, that's going to break your project if you were to use that. But using this method, no matter what happens to the global libraries, you don't care. Your project is embedded with a local library and always works no matter who opens it, or even if you open it up within 10 years later or something like that. So that's a great way of making sure your project works. Let's add another symbol to our library. Stop of getting an LED. And put it here. And then once again, let's edit this properties, edit to library edit. So I can now say save a copy as, put it in the flex test library and save it. And you can notice the second symbol is now added to the flex test library. I can just save that. And now I can keep doing this for as many parts as I wish to add. Just the LED, I can add APA 102, save a copy as, put it in the, where's the flex? Yeah, put it in flex test, save it. Let's say I need a couple of jumpers, two bridged, save a copy as, put it in flex test. So you kind of anticipate the kind of parts that you would be using for a project and keep adding them uh, initially. If there's anything that you miss as you go along, you add it using the same procedure. A couple of connectors, we can add a generic 1x8 connector, for example. Edit, copy, put it in flex test library and save it. And you'll see we've added 1, 2, 3, 4, 5 paths to the flex test library. There's an APA 102, a connector, 1x08, 2-pin jumper, LED, and a resistor. The asterisk marks indicate that it's still unsaved. So once you hit save, it saves everything, and you're then done with. You now have a library with these 5 paths available, and now we can start placing parts over here. I can just make sure that I remove this and say flex test LED. Okay, there it goes. And I can put a connector here. Here's flex test connector. So this is the way you can quickly copy parts from one library, which are global, and put it in a project-specific local library, and then use schematic symbols from that particular library instead of depending on the global libraries. It's an additional step, but as you keep working with KiCad, it's something that becomes second nature. It becomes pretty easy, and it actually makes your life much, much easier as time goes on. If you're smart, you can even do some of these things using just a text editor, for example. Copy parts from one library and paste it in your own using copying blocks of text from one to the other, for example. Or over time, you could build up your own master local library, which is, let's say, always available locally on your computer, for example, and then copy paste parts from it to your project library, for example. I don't mind usually adding a lot of parts that I may not be using because, frankly, the size of the libraries is pretty small, so it doesn't really add too much overhead. If you have or 10 parts or 100 parts. So, I just generally copy and paste a bunch of parts and put them in my local library. So that's another. So at this point, anyone have questions that they'd like me to answer? I'm happy to do that. So I just stopped sharing. Hopefully, yeah, here I am. Okay. All right. Anyone have questions on this? Let me point out, sometime over the next meetup, or maybe I'm going to show how this works for footprint symbols. But essentially, the technique is the same, whether it's just schematic symbols or footprint libraries. You pick a symbol from an existing or a footprint from an existing library, uh, save it to a local library, and then uh, under preferences, make sure that the local libraries are available and use paths only from there. With uh, schematic, you have to explicitly state where the symbol is coming from, so which library. With PCB new, it first parses the local project libraries, and if it finds the part, uses them. And if it doesn't find it within those, then it tries looking under global libraries. So if you have the same name uh, footprint in PCB new, uh, you don't really have to explicitly state, although it helps to have it marked. So that's a little bit about management. There's more stuff that I will talk about in maybe the next meetups that we do. But I thought today it would have been nice to talk about this. Any questions, people? Brandon, I assume if you make similar projects, you can copy the entire project folder and subfolders, and the folder lookup is relative and will work. Yes, that's a yes. The answer itself is a yes. You could do that, yeah. Uh, if there are no questions, I can quickly show a little trick about using schematic subsheets, multiple versions of schematic subsheets, because quite often I think that's one thing that a lot of people that are getting started on KiCad get stuck on. Uh, Sri says, looks like it's a good thing to automate with some scripts. Yes, I'm not a script guy, so I still do things manually. But yeah, it's plain text. I'm sure it's some Python script. Should be easy to parse. Global libraries, find a part and put it in your local library and be done with it. So yep, completely doable. But let me again share my screen and show you what I meant about. Uh, so here it is. So this is actually sort of a PCB with a bunch of APA 102C smart LEDs or neopixels. And it's got 5 rows of LEDs, and each row contains 5 individual LEDs. So there's a total of 25 of these. And these are the 5 sheets over here, subsheets, that contain those LEDs. So let me just enter the first one over here. And here's what you see. There's 5 of these LEDs. There's a couple of decoupling capacitors. And there's uh, 6 IOs over here, basically data and clock in and data and clock out. And then there's power supply, 5 volt and ground. So these are the 6 connections that go from one sheet to the next. That's the ones you see here. Now, the trick with using this is, you can notice it here. Over here it says the sheet name is row A, but the file name is row a.sch. And then the next one is the name is row B, but it uses the same schematic file, row a.sch. And the same thing for row C, same thing for D, and same thing for E. So the same sheet is used for all of these 5 sheets. And if you look at the properties of the sheet, this is how it goes. You give names that are unique and specific to each scheme. Sorry, the file name is common for all of the schematic subsheets that you're going to use, but you give it a unique sheet name, A, B, C, D, E over here. So that's the trick. The other thing to do is to make sure that inside your subsheet you don't end up adding net names. I found that causes some kind of trouble. So if I were to add a net name here that says data in or dat in, it's going to be used for all of these 5 subsequent subsheets, and that could cause trouble with net lists. So the tip is to not add net labels to the wires over here. Just have the hierarchical labels for input and outputs, and leave it at that. You'll notice I've still added 2 labels here for ground and 5 volts because that's common throughout the whole board. So that's okay. I can, but for the other signals, I really can't use those labels. So once you have that, if you look at any of these sheets, they look exactly the same. But once you do annotation, you'll notice that the first sheet has U1 to U5. The second sheet, that's row B, has U6 to U10, and so on. And that's how you use a single sheet, but actually have multiple instances of it. And that makes life very easy. You don't have to replicate the same sheet 5 times. So, sort of putting that out here for those who have not played around with subsheets and multiple versions of the same sheet. Okay, so at this point, I'm kind of done for what I wanted to talk about today. And see if there are any questions. Brandon Bredan, I don't know if I can pronounce it right. I'm looking for tricks to keep out areas to footprints. It's not appropriate for today's talk, then not a worry. Well, anything's appropriate for today's talk as long as it's either KiCad or FreeCAD. So let's see. Keep out areas for footprints. I don't think I have an answer for that unless someone else can tell me that it's possible. But as of now, I don't think there is a way to do it without a hack. Uh, maybe you can add a polygon in a different layer on the footprint and then edit and bring it to, let's say, the copper layer or something like that. But I'm not really certain if I can answer this correctly right now, but it's a good question. I can probably check and see if we can answer it the next time around.
Yeah, I don't know if you can hear me.
Yep, I can. Go ahead.
Okay. So I've tried 2 hacks, and yes, they're hacks. For a round keep out area, I create a very, very small pad, and then I use very large offsets. And I've had mixed results with that with the PCB manufacturer. Twice it went through without any question. One time it kept getting stuck in engineering, and they kept asking questions. The other trick that I've used, and I haven't submitted it yet to see how that works, is what you just described. Create a very thin polyline that's closed and then move it to the copper layer.
Yeah.
And then subsequently create a polygon and move it to the mask layer. And I'm going to submit a prototype and see if that gets through without engineering questions. But those are the only 2 tricks I've been able to find so far that look like they might work.
Okay, give me a second. I need to open the door. Someone's here. Sorry, that's the trouble with working from home. All right, back. So yeah, as you said, these are hacks. But to clearly understand your first hack, you said you give a large offset. So that means you move the small pad away from the origin.
Um, in the definition of a pad within the footprint editor, there's a tab for creating custom offsets,
Primitives.
typically used for uh, separating the mask layer from the copper layer,
Ah,
or the stencil layer from the copper layer.
got you. Got you. Yeah. Okay. Yeah, that could work as well, but it's a hack. And
Yes,
as
it
of
is.
now, yeah. But it's nice to hear that it worked with some places, but maybe not with others until you had to talk with them. So I think it's best to first check out with the Fab House to see if they have any questions before you click on
Yeah,
submission.
yeah, exactly. The other thing that seems to work with the manufacturers is to include a, a JPEG or a PNG file of your printed circuit board with circles and arrows and little text messages and stuff that they can use as a reference so they don't have to contact you.
Yeah, that's exactly why I use the PDF prints. So that really gives a pretty good idea for them to, without opening the Gerber files, they can see what they expect to see. So
Oh, good point. Thank you.
yeah, so schematic and top and bottom copper layers, top and bottom masks, and top and bottom silk, the edge cuts, and a drawings layer with dimensions. These are the ones that I send. Sometimes I even send the fab layer because I add extra information there on uh, parts and stuff like that. So that's mainly helpful for the assembly part side. So that helps. So having PDFs helps. Also having PDFs helps if someone doesn't have KiCad handy and they still want to check out your project. So that's kind of useful. Uh, so Miguel says, thanks. Well, thanks, Miguel. Do you have any recommendations on versioning PCB designs in GitHub? Well, I do it the hard way. If I'm working on a design and I need to revise it, I shift the earlier version to a separate subfolder called version 1 or revision 1 or whatever. And that becomes a subfolder within the existing folder structure in GitHub. So everything else remains same. When you open up GitHub, your main folder has your main version, and the older versions are then stored in subfolders with whatever revision numbers you get. So that seems to work well for me. And because, like I said, all the libraries I use are local and not global, it really doesn't matter uh, how I nest the folders or stuff like that. It's pretty painless for me. Just copy and create a subfolder and put the old version in the subfolder. That works. Let me see if I missed any other questions. Okay, all caught up on questions at this moment. Yeah. All right, so we also have HEMAL Chevli here. HEMAL is based in Dubai. He is a close friend. I've known him for a while, and he works in Dubai, where I think uses sometimes uses KiCad for his day job work as well. So he suggested that he can show us a technique where we can take a 3D model of a part, a CAD file, like a step file basically, and convert that to a footprint. And that's kind of pretty handy and useful because sometimes you can find a CAD file but maybe not a footprint. And it's probably easier to do this way than to kind of do it manually by looking at dimensions in a data sheet because that's really a very painful process. So, Hemal, if you want to take the stage, good to go.
Sure. Can you hear me?
Yeah, loud and clear.
Uh, okay. All right. So thanks so much for the introduction. So I'm gonna start sharing my screen. Um, and what I have here is just a simple circuit with a resistor and LED and a battery holder. And on the
It's the
PCB
badge of a
side,
billion conferences.
Yeah, absolutely. Um, so this was one of the recently I had to do this at work. So I was using this battery holder part, and let me open up the PDF for that. So this is the data sheet of the. Just a second, rotate it the other way. This is the data sheet of this part, and uh, the only time when you want to use your step files to use to be converted into footprints is should be used rarely. You should always follow the data sheets to draw your footprints. But under certain cases, when certain data is missing, you would need to go this route. So as you see here is uh, this whole battery holder doesn't sit flush with the PCB. So there is like an offset. So there are some posts here which are above the PCB. So I already have converted this into a 3D model. So you can see that there's a lot of space in which you can insert things around. Normally, if this is the only information you had, you wouldn't put your LED diode somewhere here. But here you have enough clearance to even put it here. It wouldn't make any sense to put a LED here, but
Yeah, prove
if
your
you want
point.
some, so that was one of the reasons I used this. Now in the PDF, there is no information of where these three posts are in terms of measurement. It only shows it's there, but I couldn't find any information on how long they are and where they are spatially located and how far of the center they are. So let me just fire up FreeCAD. So I downloaded uh, a 3D model from their website. Now, for downloading 3D models, I follow these steps. First, I look up on the product page on DigiKey or Mouser. They usually have those already there. If it's not there, then next step is I go to their manufacturer's website and try to download it from there. And if that's not available, then I start looking at community built models like on GrabCAD or 3D Content Central. So first, let's fire up FreeCAD, and I already have this KiCad Step Up plugin installed. Um, and here I would insert. So I already made this footprint from the data sheet without using the steps that I want to show you. Uh, so first, let's import the step model, which is here. So this is the step model I got from the manufacturer's website. And first step is we need to project what we need of all the sketch over here. We need to project it on a 2D plane. So in order to do this, there is a button over here. It says 3D object to 2D projection. Now, the interesting thing about this is it will project whatever you are looking at into a 2D object. So, for example, if you're looking at this orientation, and if I click this button, it would create the same lines in 2D. So you have to be careful with that. So I'm going to delete this now, and since I need just the bottom part, so I will click on the bottom, and then I'll click on the projection. So sorry, I need to select the part and then project. So now we see we have the drawing of the bottom of the shape. All right. So now we need to convert this into a footprint. So what I would do is what I did in this for this is I only needed the silk layer. So I converted this into a silk layer and then I exported as a footprint. And the pads I did them in KiCad. from the datasheet uh, information. So once you have the projection, you click here, and then you have to convert that object into a sketch. So once you click on this button, it is converted into a sketch. So pretty much right now, what I need is here. Uh, Now, if you go to the on the menu bar and click on demo, and there is a footprint template.fc.std file. So when you open this, you see it needs these all layers to create a footprint. So it has to be in this standard, because when it is exported, these file these layer names would be used in the footprint file. So since I need what I have here on the silk layer, I will copy this name, and then over here I will rename it to f underscore silk s. So this is a standard which is followed by this
Simple,
script.
quick question.
Yeah,
Those
sure.
so obviously those numbers have some special meaning, right? I mean, it says fsilk
Yes,
underscore 2.16, so that's important, I guess.
yes. So these numbers, these are the thickness of the line
Ah,
that will be drawn on the footprint.
okay.
Yeah. Uh, so right now I just have the silk, and we'll need the reference and the value. So I'll copy this as well, and I'll put it on my part. Now here we need to create a new group, and then I'll just call it as 1025 underscore FP, and then move all of this into this group. So once I have this, I will click on this button, which is footprint editor and exporter. So once we do that, I'll just give it a name. As you can see, I've done some couple of tries. So now that footprint is pushed converted into a KiCad footprint,
Amazing.
and yeah. So since I'm using KiCad 4.0, I have to close all the windows in order to reload the library. So I'll just close it and fire it back up. And if I wish to add the footprint here, uh, we have, um, so this is now exported into my project. And I have the now information of where these posts are. So the one uh, that I used is this one. So in this, I've also added the fab layer. So usually when I send for production, I always use a fab layer for the assembly house, because this is they will know the outline, and on the fab layer they will only have the references on the fab layer. So uh, since this is not assigned with the footprint, these two are assigned with a 3D model. So now in the next step, what you would generally do is you just go to the footprint editor, and open that part, and then from the data sheet you can add the pads here and change the sizes, etc. You can also get rid of all the extra stuff that is there. So uh, look at the pad as well. So the pad information, I still keep it from take it from the data sheet, and not from the and not follow this here. Uh, there are certain models in which you can have these pads which are on a separate layer. So I will link to uh, a video which is by Maurice. in which he shows how you can use the step file to create the pads, but the step file should have the pads as a separate group in the step file. So it's not always that you would have the pads drawing in the footprint. And here, if you there's no 3D file, we can always assign it from here and just add the 3D shape. So this one I think won't be aligned because we haven't used sorry, yeah, this one is not aligned. So we'll need to once this footprint is created, let's say this is the footprint. Since I've added the pads, they're not in the right uh, location. Let me just bring back the things and put it in the ballpark. So one pin is here, and one pin is here. Okay, so from the footprint, I think the thickness is, we need a thicker circle. Mounting holes is 1.52 diameter. So the size is 1.52, and the size I usually keep it twice the hole size, so it's 3 roughly. Here also 1.52, and the size is 3. Okay, so since now we have this footprint is ready to is ready. Now we can follow the usual path in assigning a 3D step file to a footprint. So I'm going to create a new file, and I'm going to insert the footprint. So I'm going to load the footprint, which is over here. So now we have the footprint loaded, um, and we'll have the next step is to add the step file, which is like so. Now you see this is not aligned. So first we will select the 3D object and rotate it 90 degrees on z-axis.
Yeah.
So we can see it's a bit off. So we can use these offset translate functions in X and Y and move the 3D model in this location. So you can see when I click here, it's going in the opposite way from where I want it. So I'll just add a negative sign here and try to align it as much as I can with uh, the silk screen. Here as well on the Y, so it's going in the right direction. Okay, so this is good. And now we'll look at the Z. So Z is already aligned. So, okay, there is one issue I see here. So, okay, the posts are not matching with the posts over here. So you see, they are kind of mirrored. So this is also one of the caveats that you need to take care of. So in order to fix it, let's go back to the our footprint here, and we need to mirror it here. So let's click here, and I will rotate it on. Let me get my bearings right. So I will rotate it on the x-axis. So it will flip 180 degree in a way. So
Yep.
now we have the silk rotated. I'm not sure how we'll go back here. Okay. I don't know if this will be translated or not. I'm not sure. Since I converted it, let me try to convert it back to an object. Okay. So I'll convert this and put it in over here. And again, rename it here. And then I will delete the previous one. And now when I export it, okay, I need to select it and then export 1025 uh, live one. Okay, so this is the new footprint. Now I'm not going to add the paths in this one. So let's just create a new one and import the live KiCad that we just created. And then we add in the step file. Okay, and let's rotate that again by on z-axis.
Yeah.
Yeah, still there. Okay. Hmm. Okay. Let me do the whole thing again. It'll be like a good exercise.
Yep.
Okay, so just
All right.
gonna close everything.
All right. Meanwhile, Drew, did you find the project 3D to 2D tool?
No, I'm
Sorry.
still looking for it.
Okay. So, Hemal,
I have trouble, like I'm not familiar with these icons, so it
Okay.
takes me.
Okay. Sorry. Maybe I went a bit fast. So thankfully, we'll be doing the same thing again.
yeah.
Okay.
Yeah.
So let's start fresh. And so we have the KiCad, and I have selected the KiCad step of workbench. I'm going to click on a new part, and I'm going to
So,
import the
Hemal, let me
yeah.
hold you up here. What you
Mhm.
see here on Hemal's desk now is all of the tools that are available in the KiCad step up. The floating toolbar is the most widely used or the most commonly used tools, but there have been a lot of new additions to this whole workbench. In fact, a large number. Today we're just talking about one, but maybe in future we can talk about others. So,
How do you get the
uh,
floating toolbar? I don't have the floating toolbar.
uh, if you
Okay.
look at the pull down list in FreeCAD, you get a list of all of your installed workbenches.
Yeah,
And you should see KiCad Step Up. It's probably usually at the bottom somewhere.
yeah, I have it open,
So
but it doesn't pop up.
yeah,
I just toolbar.
yeah. So that
Okay,
happens.
you can probably
I
do
think
view toolbars and enable it, I guess. Hemal?
so. If you import a footprint or a step file, this should pop up on the floating thing should pop up when you
Okay,
import a footprint or a step file.
okay. Yeah, I downloaded the same step file you have, so I'm trying to play along.
Okay.
Thank you.
Okay.
Okay. Okay. Maybe I should have put it on GitHub or somewhere so we could also everyone could join in.
It's annoying. You have to put in
Okay.
your email, and then they email you a code to put into the
Exactly.
website.
Yeah. Yeah. I'll always use a throwaway email for these kind of stuff. Yeah. Okay. So let's import the step file. So this import button is also up here. That says
It's a cylinder with a plus mark on it.
import 3D model, which is gonna import this and then go on the bottom, and then this is the uh, projection icon that you need to use, 3D object to 2D projection, which creates the shape of the uh, basically projects all the sketches onto a 2D plane. Now let me rotate it here. So I'll just rotate it on uh, z-axis. So as you can see, it's not aligned. So what I'll do is I'll rotate it on x-axis twice, and now we see that this is now in the right orientation. So I'm not going to align it at this point just yet because this will be converted into a footprint anyway. So let me hide this 3D model,
So you did
and
a Z,
this
Hemal, you did a Z rotation as well as an X rotation.
Yes, yes.
Okay.
So before, when you do the projection, I'm not sure where it uh, takes the projection from. So
Okay.
before it was like this. So you had to like mirror it.
Flip it
So the
over.
best way I could think of it, yeah, just flip it on the x-axis.
Yeah.
So if I show it like this, so it goes
This
like
looks like
that
a
and then
mirror.
goes like
This
that.
looks like a mirror of what you want. So you have to flip it over and then rotate it to get it in the right location.
Exactly. So
Right.
now these posts are in the right location.
Yeah. Yeah.
Uh, okay. So let's go back to the demo file, the footprint template, and let's copy this. And oh yeah, before we change the name, we have to convert this to a
Object.
sketch
Object to
object
sketch.
to a sketch.
Yeah.
Yeah. So once this is converted, we can rename it to this from the demo, and also add the reference and the value. Copy it, and then go back and just paste it here. And so it will be like this. So you can always move them over here, or you can also do it in the when you are in KiCad, you can move them and change their sizes. I'm comfortable with KiCad, so I usually do that in KiCad. Now
Also,
here we'll create.
let me add Hemal. The other thing you can do
Sure.
is from this 2D drawing, you can also extract some dimensions. So if you want probably to know the BCD uh,
Mhm,
on which the three posts are located, I'm guessing it should be
mhm.
possible to get a measurement of that.
Okay.
Not sure how we can do it right now, but I'm sure we can figure out a way. And
So
because you can connect the center point of those three circles as a triangle, and then from there derive
yeah,
a circle that goes through all of those points. And,
yeah, yeah, absolutely.
and the other thing you can
I
extract
think.
from here is the diameter of those posts. Once you have that
Mhm.
information, you can probably do all of this in. I mean, you can create holes for these posts in your footprint, I guess.
Hmm.
Yeah.
Yeah, you're right. So I'm an absolute noob in FreeCAD.
Yeah, we
So
can
I just
do this as an exercise next time.
sure. Yeah, yeah, we can definitely try that. Okay. So
Uh, I
moving on,
think just one comment. So if you are familiar with if you are familiar with that sketcher workbench in FreeCAD, it makes it easier to make the measurements and align
Exactly.
things like perfectly.
Yeah. Thanks for the tip, Sri.
yeah, yeah.
Yeah,
That's why I
thanks, Anil.
selected the sketch. And I thought there must be like a measure tool, but I think this measure is always there. It's part of like a global menu,
Okay.
which measures.
Yeah, Drew's got a question. Drew says, I have the shape
Okay.
2D view. What do I export to?
Um, you have the shape 2D view. Okay. So now we have to click on the next object, that is 2D object to sketch. So that will create some like a symbol like this, like a triangle and a circle intersecting. So that means it is a sketch now.
So
Once
essentially,
you
Drew,
have that,
the first step is done
Yeah.
is create an object, but that's not really a sketch per se. And then you have to do another operation that takes the object and then makes it into a sketch consisting of lines and arcs and stuff.
Is that so? I've selected shape 2D view. Then what's the next thing I click on?
The icon
this
next
one.
to it.
2D
I
to
have my
D. Oh, 2D object to sketch. Okay.
Yeah, yeah.
All
So
right.
yeah. So you're taking a 3D object and creating a 2D object out of it, and then
Right.
taking the 2D object and making a sketch out of it. That's the steps.
Okay. And then what do we convert the sketch to? DXF or?
That's your essentially your footprint. So we rename it as a silk layer, and Well, HEMAL will carry it on from here. That's what you do.
Oh, that's
HEMAL.
what. Okay.
Okay.
And
So yeah. So you can open the demo file from the KSU tools and then going to demo and footprint template. So this will open up a file which is here, and these are all the various layers that you can have on your footprint. So what it does is basically converts these sketch to these layers. So here, since we just need the silk layer, I've renamed this into a silk layer and also copied the reference and the value from this footprint. So you basically just select both of them, click on copy. The copy button is a bit weird. It seems like it's disabled, but it's not. Uh, and then you just go ahead and paste it here. So once you have that, these three information, you need to click over here and create a new group for ordering objects. So basically creates like a subfolder, and you have to move all the three objects into this group. And this group you can rename it to usually the name of the footprint. And once you have this group, which has all three listed over here, you click on this icon, which has a footprint and a red arrow on it. It says footprint editor and exporter. So as soon as you click on it, it will ask you for a name. So I'm gonna do another one and save that. So it exported the file to. So basically, it wrote the file. Now, if you have something else over here, like instead of f dot silk, if you have something else, it would be. Let me see. Let me just show you. Um, so that f dot silk layer is used over here, and then the width is used over here. So if you rename it, if you don't rename this correctly, then it will be translated. It would still export it without any errors, but over here it will use the name that you used in over here. So
Okay.
if I call it like ABC, it would still export, and then I export it. It would still export without any errors, but it won't be able. You won't be able to open it up in KiCad,
Right, because it's got the
or
wrong layer.
it won't. Yeah, it wouldn't find the. Okay,
Yeah,
it
there's no
didn't
layer called
write
ABC.
the.
It doesn't export that layer at all.
Yeah, I think
Okay.
last time I tried it, it did that, but this text was a bit different. So
Right.
this name comes from here.
Okay. What happens if you just
Here's what.
export as f dot silk, f underscore silk, but without the width information? So instead of f underscore silk underscore 0.16, if you just do f underscore
Mhm.
silk, does that work?
Okay,
Let's check.
let's try. Uh, so
Yeah.
like this.
Yeah. I'm thinking it should
And
default to some default value. Let's see.
okay, so let's open. So no, it didn't. So I think
Okay.
it's a script which
Yeah. Yeah.
expects
Yeah.
that thing to be there.
So those names are hard baked into the script. We have to use those.
Yeah, that's why they have provided this footprint demo.
The
So
template.
you have
Yeah.
to use.
I think so. You have to
Yeah,
use this template to name things. Yeah, that makes sense.
yeah, yep.
where was the create group
Okay.
button?
The which button?
Next to this.
How did you create the group?
Uh,
Oh, okay. I see. Thank you.
yeah.
Or you can just right click on your on the top of the hierarchy in your FreeCAD, and you should get create a group.
Yeah, like so.
Yeah.
Okay. Um, so I think I already exported this as live 2, I think.
Yeah.
Let me see if the uh, okay, so I'll have to restart it. Okay.
Yep. There
Okay.
it is.
Yep. So this is the footprint that is with the right orientation of the posts. We can go ahead and add the
Ads.
pads and stuff. Yeah. Let me just quickly do it just for the sake of, and then save it. Now, if you go back in KiCad and create a new file, uh, we are still in KiCad setup workbench, and we import the KiCad footprint, which was live too, and this gives us the new, gives us the footprint that we already created, and then we import the same,
Step 5.
and yeah, the step file, and uh, the only thing needs to we need.
You need to
Oh
nudge it a
man,
bit. That's all. Yeah.
yeah, I don't know why it's still, maybe, yeah, this, the posts are still in the wrong direction.
Oh.
I think I've created too many files here. Let me just I'm not sure which one was I like to I want. No, it's this. Okay, so I'm just gonna do it one final time again. So
Yeah.
just
Third time
bear,
lucky.
bear, yeah, third time's a charm. Okay, here we go. We import the step file. Oh, create a new file first. Import it here and go on the bottom, and then project 3D to 2D.
What if you project it
So
from the
this
top, Hemant?
from what?
Yeah, from the top view. If you project it from the top view, then you don't get the post, I guess.
Yeah, so if you do from the top view, you'll get this information.
Ah, okay, got it. So that's not useful.
Yeah, yeah. Okay, so Z, and then I'll flip it on X. Okay, now this is fine. We'll go back to the KiCad workbench. With this selected, we'll convert it into the sketch, and we'll take this name, paste it, and also take the reference in the value, and paste them here. Create a new group, call it 102, 1025, then move it over here, and then
Export.
third time is okay. So this should this should work now. Okay. So for now, sorry. Now we'll import the footprint, which is this, and then import the step file, and then okay. Now we see it's aligned.
Ah, finally. Sweet.
Yeah, finally. So okay. So now we just uh, go on the top, and then nudge it a little bit. You have to select the object first. Also on the Y
Sometimes
direction.
if this is difficult, you can choose the wireframe mode so that you can see invisibly through the object.
Or you're right. I think it's in the appearance. No.
Usually you see
Raster,
the
yeah. Here it is.
yeah.
Got it. Um,
Yeah.
okay, that sounds about right.
Yeah.
And let's go back in the flat lines mode, and we select this and we export the step file and the VRML.
We are
Sometimes it asks me to save the file. When I don't, my KiCad hangs up, so I usually save it. So it's just a good idea to save it, and then you can delete it later on. It says already the file already exists, so I'm going to rewrite it. And then it asks a couple of questions regarding the mesh deviation. I
okay.
always keep
Go
them
slow here.
as
Yeah.
defaults.
Say okay, and
Yeah.
then go slow on this.
Okay.
Yeah. Click
So
OK on this.
so here it will ask you for Anul. You want to go ahead or should I
Yeah,
go ahead?
just click OK.
Yeah. Okay. And then the crease angle again. I'll
It's
click
fine.
on OK.
Okay, this is
Now
where you
here
can
it says
set colors. So go ahead, Hema. I wanted people to see this.
yeah. So you can change the. So it says the original is this one and new is this one. So if you just click OK through all of them, so depends on how many materials you have on your step model. It will ask you questions for each of them. And let's say you want to change it. So let's make it like really jazzy. So I'll have let's have a green body or a red body in this wherever this is, and then I click OK. And this gray I want to have it like let's say LED green. So it will take on that color. And since these are the only two materials on my step file, it only asks me twice. And now it asks, since it's already there, it says if you want to override. If it is not there, it would just say that it exported. So now these are the colors that we made for this one. Now when we go back to our uh, KiCad
Footprint editor.
and footprint edit, add a 3D shape. Uh, Let me remove this one. Go to desktop. And then when we go back into the 3D view, it will show us this model which is aligned.
Sweet.
I think, yeah. So yeah, that's how you create footprints using your step models, and then also import your files from step files to your KiCad environment. Uh, any questions? I'm sorry, I'm not looked into the chat window just yet.
Uh, None yet, but yeah, if there are any questions, I think happy to answer.
Yeah.
That was
Can I
nice,
stop sharing
Hemal.
now?
That was
Thank you so much.
really into Hemal. So I found it very good. I actually did not
Okay.
know about this what is it called plugin. Okay.
Okay.
Oh,
Let's
that
see.
that plugin is amazing. I love it. I mean, uh, every time I talk to Maurice, I can't thank him enough for the work he's putting in on this, because that's really made a really great connecting bridge between FreeCAD and KiCad. Without the step-up bench, these were just two separate programs. Now it's like almost they're one kind of entity that you can go back and forth. The great thing with his KiCad step-up workbench is you can do a lot of things. For example, if you import a step model of your PCB, you can move certain parts around, because let's say you're working on an enclosure and you want an LED at a slightly different location, and then you can push back the new location to KiCad. That's really interesting. That means you're working both ways now. You
Wow.
do And it's really handy when you're doing mechanical design at the same time as you're doing the electrical work. So you want certain knobs or connectors or LEDs or indicators at certain locations, and you can probably only view them properly in FreeCAD, for example, or your enclosure is in FreeCAD, whatever you've done. So you can do things like shifting the position of the components themselves and then have it reflect back in KiCad. You can also edit the edge cut layer and have that reflect back in KiCad. So there's a ton of stuff. In fact, half of it even I haven't been able to explore, but he's added a lot of functionality that makes you go back and forth between the two tools very easily. So I just love it.
Yeah.
One more feature I really like about FreeCAD on this plugin is the collision detection.
Oh yeah.
Yeah, I'm just gonna share my screen quickly again. So if you have multiple parts here, I'll not be able to demonstrate it here, but if you have, let's assume there is an enclosure for this device, and you click on multiple parts and you click over here, which is detect collisions interfaces. What it'll do, it'll subtract these two objects, and it will show you if your mechanical design is interfering with your PCB or the components on the PCB. So that's one of the very helpful features that I've used in KiCad to simulate the design of the PCB, especially when you're doing the placement of your product when a mechanics constraint is there. So I just wanted to point that out really quick.
What does it look like when it doesn't? When there is a collision, can you nudge it and then make it?
Yeah, you can nudge it and then push those new locations back to KiCad. So Drew had a question about being unable to open a step file. I think it's a FreeCAD quirk where if the step file is named, the extension is named with capital letters .step, it probably doesn't see them. And you have to use lowercase names. Can you check and let us know, Drew?
I haven't had any issues with that per se. Okay, but does it work when it's in lowercase?
No, it looks like it's still doing the same thing for me, which is okay. It's just when I do file open, it creates a new FreeCAD file. And I was trying to I wanted to open it up in the footprint template because I was having trouble creating a valid one, which maybe I was just not doing the right steps. So the issue I was having.
You want to share a screen, Drew?
Yeah, maybe try importing it instead of opening it.
Oh, you need to use the import icon within the step-up bench, not the FreeCAD file.
Okay.
Oh, right. Yeah. You have to use that the icon with the cylinder.
Yeah, so I'm using the icon with the cylinder, and it says that the selector is *.step, but I don't see the file. I do if I do file open, but is that going to be incongruent with the workbench then?
Oh, I guess not. Something weird going on.
So the reason I was trying to do that was I can export from the template fine, and that opens up in KiCad. But when I was trying to do it on my own, I was getting a footprint that just had it just said like reference or something like it was just had the reference and the value and nothing on the footprint. But just to be clear, do I need to have the reference value and then the fsilk, and those are the three things that I need in my
yes. Yeah.
Okay.
That's true.
Yeah. Okay.
All right, you can let us know if it works.
Yeah.
I am hoping since this is on YouTube Live, you can review it back so you can see if you've missed any steps And if you have questions, then you can give a shout out on Twitter or wherever, and either me or Hemal can help you out.
How do you create the reference and the value tags?
You just copy from the template
Oh,
file and
copy.
paste it.
Okay. All right.
Okay, Miguel needs to know regarding PCB depletions, is there any repository with examples for that? Miguel, can you explain what you mean by PCB depletions? Miguel? Ah,
Sorry,
wondering
I'm here. So I mean, when you bend your PCBs, is there any way to model that situation when you have bending your PCBs? That's what I mean.
okay. You mean like a flexible board?
Yeah.
Okay, yeah. So I've used a hack. I'm not sure, but I think it works. FreeCAD has a workbench called what's it called? Sheet metal. So it does what it's supposed to do. It lets you model sheet metal work, and using that, I've been able to model flexible boards. It's quite easy. Let me see if I can do a quick demo of that. Let me run up FreeCAD. And while it comes up, let me share my screen. Screen share, entire screen share. So first thing is you need to get the sheet metal workbench. And start closing down stuff that I don't need. So. Okay, so here's my FreeCAD. I'll get rid of the Python console. Let's make a new one. And the workbench you're looking for is called sheet metal. And to get this workbench, you go to Tools, Add-on Manager, and in Workbenches you have this whole list. So you look around for wherever sheet metal is, PQR. Yes, here it is, sheet metal. And you get a GitHub link for where it is hosted. So you can either, but the easiest way is to just install it from here. Once you have it, you have a certain amount of basic tools that are available. So let's start with something simple, which is to create a part design. And as we usually do in FreeCAD, you create a body, and within a body, you create a sketch. I choose a plane, something random, say okay. So I have a 2D drawing board here. Let me just draw a square, make the two sides equal. Let me just make it congruent with the, give it a dimension, let's say 50 mm. So I have this sketch, and because it's a PCB, I can extrude it to a thickness of, let's say, well, flex PCBs are thinner, let's say 0.1 mm. I'm not sure. Drew, do you know what the standard thickness is for flex?
I need to check.
Okay, we'll just go with 0.1.
Yeah, very thin.
Yeah. So here's your, and well, it's pretty thin, so you have to zoom in a lot. But let's say you want to add a part that folds down over here at a right angle. Okay. So I zoom in. I select the sheet metal workbench, and I choose the face that needs to bend down, which is this one over here. And you can see it activates these couple of tools over here. And I choose the extend of all from the side face of the metal sheet icon. So that's the blue one that my pointer is on right now. Once I do that, you get a basic bend that's something like this. And it has certain default values, which you can see here in your project, in your folder tree under bend. You'll find these options over here. So there's a material bend outside and then inside. Okay, this changes the way it uses the radius to match with the inside surface of the arc or the outside surface of the arc, for example. So let's just choose the standard outside. What angle it needs to be, you can make it 90 or minus 90. Oh no, minus 90 doesn't work because you have to do reversed. So that's another setting, but I can say, let's stick with 90 here and then I'll show you the other angle in a different one. Here's the invert one. Invert true will mirror it in the other direction, like so. The length is the extrusion you see over here. So it's 10 mm. I can set it to 5 mm first. So that reduces that. Radius is right now 1 mm. I can set it to 5 mm, 2.5 mm. That's 2.5. So that's one bend on the PCB. Right, so. And then you can choose this face over here. Oh, there's another thing. Let me show you that works over here. It's pretty handy. You can choose this face and extend it. Oh no, extension. Oh, where's the code? Let me try and think. Okay, it's here within the bend settings itself. Here goes. The extension parameters, that's important. It says here extend 1 and extend 2. So let's say I extend 1 as 2 mm, and you'll see it goes beyond over here. And I can make extend 2 as minus 3 mm, and you can see it goes in over here. And there is a way to relief factor. Relief factor 2 adds pardon me as I do this as we go along because I don't use this workbench all the time, but okay. So usually in sheet metal you want to add a slot over here so it helps you to bend the sheet, and those are parameters you set using this relief, but I can't seem to get the actuator right now, but you get the idea, I guess. All right, so let's add some more stuff here to this face, maybe another bend. Add another bend, like so. And we can add extensions to it as usual. Extend 1 and 2. This can be back to minus 2. This can be 3. So oops, that didn't go well. There it is. Yeah, it's a bit quirky. It takes a little bit of getting used to, but hopefully this gives you an idea. You can start making sheet metal work like this, but essentially think of it as if it's a PCB. And here's the nice thing. Let's see if we can do this. Bend, uh, unfold. A bit work. Right. Let's see if we can unbend this. So this tool icon that says make it flat, but I can't seem to get that working right now for some reason. That's the trouble then. Okay, so I just chose one face and I can see this icon active now. Let's try if it works now. Create projection, separate layers. It's gonna say okay with all of this. Unfold is failing, please. Ah, okay, there. Well, that's helpful. I need to select a face before I unfold. So here's a face and then I say unfold. Okay. And there it is. So that's the unfolded sketch. And that's the actual sheet metal. So that's kind of pretty handy because you want to start out with this and then bend it like so. This also helps you measure the length of your board, so you know if your dimensions are right. So that's how it works. Probably still needs a little bit more work. It's not a really polished workbench, but it gets the work done. If you have a little bit of patience to play around with various property parameters over here for each operation that you do. Basically, you can bend uh, a face, you can extend it, you can inset it or outset it to extend in certain directions. You can add cuts at these bends, so that makes the sheet bending operation easier. It's flex PCB, you don't need to do it actually, so that's okay. But that's a very quick rundown of the sheet metal page. Check it out, it's pretty handy. And if you have troubles, then I'll be happy to answer any questions that you guys might have.
With the flexible PCB tester, how did you bend that one?
So that was a bit different. I didn't actually use sheet metal over there. Let me open up.
Yeah. Okay.
Am I sharing my screen yet? I lost track of that.
Which one?
Am I sharing my screen? Because I've lost track of it.
No, just stop.
Okay, let's see.
Well, I was just trying to, I missed how to create the original object, so I was just trying to open something up and manipulate it. How do you just like make a shape? I missed that when you first started there, you made a square or something?
Yeah. So, okay, let's just delete everything and start all over again. So in KiCad, in FreeCAD, you usually start off with the part design workbench. That's the starting point. And when you do that with a new file, it asks you to create a body. Now, a body is one part of an object. So if you have let's say an enclosure with a bottom and a top, that would be two separate bodies.
Okay.
Right. So within a body, you want to now create a sketch and then apply different 3D operations to it. So the first thing is to start off with a two-dimensional object called a sketch. And that's what it offers you to do. You've started a body, and the next step is create a sketch. It needs to know in which XYZ plane you want the sketch to be located. So that's looking down on it. That's the YZ plane. And say, okay. And this brings up the two-dimensional drawing toolbar, the sketcher. And you've got tools to draw stuff like circles and squares and splines and so on. And ways of constraining those things. So make lines parallel, make things equal along an axis, make things perpendicular, tangential, and so on. So for this case, let's just create a rectangle. So I use the rectangle tool and click once, click second time, I get a rectangle. Press the escape key. I want the two sides of the rectangle equal. So I select any two sides, and this is the equal constraint. So that makes the two lines equal. I still have 3 degrees of freedom left. So that tells me how many more dimensions I need to apply to this object before it becomes fully constrained. The three constraints right now is the XY position of any one of these vertices of the square and the length of one of the sides of the square. So that's the three things left. I can take a point and select the origin 0, 0. So these are 2 points, and I can say make these 2 points coincident. So it snaps to the center of the XY plane. And now I have just 1 degree of freedom left. That's a side. I can select a side and say its horizontal length is 50 mm. So now the sketch turns green from yellow, which means it's a fully constrained sketch. And you close it. You can then see it in 3D view like so. And then you can create a pad. A pad is an extrusion. That means you add a thickness to this sketch. When you do pad, it asks you for a dimension and what is the length of that dimension. So let's say 1 mm to make things easier. That gives you the basic object to start with. And now you can, pull up the sheet metal workbench and start adding stuff to it. Like take this face, add this, take the other face, and add a bend, but in the opposite direction. So I invert true instead of invert false. And there it is. And each of these is an independent object. If I hide bend 001 and unhide bend the first one, this is what I get. If I hide this and show the pad, there I get. So the progression is you make a sketch, you make a pad out of it, and then you start adding bends and extensions to it like so. And you keep progressing from there. Make sense, Drew?
Yeah. Yeah.
Cool.
Do you ever then import like a board from KiCad to use as your base that you're going to bend?
No. So, okay, let me show the flex tester that you mentioned. Okay.
Or let's say you had like a shape of something in KiCad. Could you bring that in and bend it?
You could with a couple of extra steps, meaning you would have to get the outline as so you can export outline as a SVG from KiCad. Import the SVG in FreeCAD, convert it to an object, then convert it to a sketch, And once you have the sketch, you can then apply a thickness to whatever is the thickness of your flex PCB, 0.1 or 1 mm, stuff like that. Make sense?
Yeah.
It isn't, I mean, it's a little bit convoluted, but yeah, you can technically do it. So, where were we? FreeCAD file, here it is. So, this is what you were talking about, right? And the green PCB you see is actually just the VRML import from KiCad. So I can hide that. And I used it just as a reference starting point. But the flex that you see here, I did was by, I hope I can get.
You're not sharing your screen, Anul.
Oh, sweet. Wait a minute. How about now?
Yeah.
Okay. FreeCAD. Everyone see the FreeCAD now?
Yes, yes.
Okay,
It's
sweet.
visible.
So the green one is the VRML import from KiCad. I just got it as a reference. I'm not really using it per se, except as a guide. So I can hide that. I can hide the battery. And this is the flex that Drew was mentioning, how I modeled this. So this was not done using sheet metal, although in hindsight, I could probably have done that as well. Instead, I just went the regular route of making objects and bending them. Let me see if I can get it. It's a bit convoluted here, but I hope I can find sketch. Let me just delete the fusion. Makes things easier. Sketch 4. Here it is. Sorry. So this is what I did, and I started off with this. So I made this D, the part that was going to stay flat. This part doesn't bend. So I made a sketch for that, and then I made it into a pad like so. So that's the sketch, and that's the pad. Let me hide the things that I don't need. That's the first pad. Then I made this bent part, which was actually just modeled. Sketch, not the pad. Yeah. Which was modeled like this. So I kind of guesstimated some of these numbers to create. I knew what was the length of the PCB. So then I figured out that I have a flat length of PCB over here, and then a circular arc, another circular arc, and a straight part, and all of it adding up to approximately the length of the PCB. Well, half of it because I'm just mirroring everything later on. So these numbers are kind of guesstimates. Maybe if I use the sheet metal bench, this could actually have been much more accurate on hindsight. But yeah. So I just made this sketch, which is essentially series of arcs and lines, and then gave it a thickness by making this pad. And then I needed to add cutouts and stuff like that. So those were the subsequent operations that you could see. I added these. I added this pocket, which wasn't there in the earlier version. So I took this and I added a pocket like so by adding a sketch and creating a pocket operation instead of an extrude or a pad operation. And I added a couple of pockets at the top. Here's one, and here's the second. So this is what it looks without the pockets, with one pocket, with another pocket. And then I just mirrored the whole thing on the other side and got this part. Combine them. So yeah, this is how you can kind of model flexible PCBs using the sheet metal workbench. But maybe you can even do it using regular, FreeCAD tools, like I've done in this case. So you can do it both ways, whatever is easier. Okay, let me open up chat window, look at queries. I think I've answered most of them. Morgan, with this tool, I usually just start with a flat cube, the thickness of the material you're working with. Yeah, it makes sense. Flattener has some issues. I think there is a macro that might work better. Okay, so that's the thing with FreeCAD workbenches. You can have tools in either two ways, either add a workbench or use a macro. Macro is what was originally being used, and then workbenches were added, custom workbenches. So in some cases, macros probably still work better because they're everything, whatever, Python code. Sri says that the unfold part can be used to print 2D projection on paper for trials. Yes, absolutely it can, which Morgan confirmed. Sri, looks like I need to head a bit away from it. Okay, he's gone. Thanks. All right, anyone else got any questions? Let me know. Okay, is my partner in crime here, Hemal? You're still around. True is around.
Here.
Yeah. Cool. All right. Wow. We've
2 hours. Wow.
yeah, yeah. We've gone beyond the original time, but it's okay.
Yeah.
It's time spent useful. I like doing this because I get to learn a lot myself. So for me, it's not a problem at all. If people have questions, happy to answer now or later. If none, maybe we can call it a wrap.
I was still, I was going to try and post screenshots. I was still having trouble getting that part to get for a footprint to come in from FreeCAD. Like the template works fine, but my attempt did not.
So you are still unable to import a step file?
No, I was able to. I was trying to create the footprint from the 2D projection like we were doing earlier.
Okay.
And it works fine if I use the template. But then with my own projection, it was not working.
Okay.
And I'm wondering, maybe that's because I was creating it myself and the files look like they're named correctly, but
so first question, which version of FreeCAD are you using? I hope it isn't very old.
it's 018. I
Okay.
downloaded the app image.
The other thing is when you open two files in FreeCAD, I can't remember, but sometimes you can see both the folder trees simultaneously. So you have to make sure you're copying and pasting stuff from the right file into the right destination.
Does the name of the file or the group matter when you're
the name of the group doesn't matter because that's the name that is exported as. So that's the name of the footprint in short. But inside of that group, the names of the various layers are important. So Silk needs to be the name as mentioned in the template and so on.
Right.
And I think whether you like it or not, you have to add reference and value items as well, because I'm guessing it doesn't export without it.
Yeah, because what I see in KiCad is just you just get, let's see here. It just says rough and value, and then edit pad numbers is text that I see on the silk layer. So I think something's going wrong with the workbench, I think. So this is. I remember at one point you. Yeah. At one point you had edited.
Screen. Sorry, we kept doing that together.
Sure. Well, I was going to say at one point you edited a file. Do we have to do that? I know.
No, you don't.
Okay.
Can you share your screen? I think maybe it'll be. Let's see what's going on.
Yeah. Let me. I haven't done that yet. Let's see.
Bottom left, next to the raise hand.
Yeah. Can you see my FreeCAD now?
Yep.
So I was having trouble actually finding the file. I had a FreeCAD file somewhere, but then I was playing around with the sheet bench. But if I just go and do this again, so KiCad step up, and then we do the 2G projection, right? And then
okay, so you used the wrong page to do that. So look at the bottom view. Okay, first of all, go back to your project tree and delete the stuff that you've done. Yeah, make sure you have just the step file. Yeah, that's good. Now look at the bottom view. Yeah, flip it one more time.
Yeah.
Yeah, that's the one. Now do the projection.
Maybe the model rotated before, I think.
Okay, can you just start a new? Get rid of everything, start a new page or whatever.
But I didn't really care if it's like accurate. I was just more trying to get to the footprint part.
Okay.
Yeah.
Okay, let's go with that then. Let's do the projection,
and then we then create our sketch.
Yeah.
And this is the thing that needs to be named. That specific thing, right?
Yeah. Can you look at the 3D view in this isometric while you're at this? Go back. Yeah. Look at the 3D view of this.
Isometric?
Yeah, isometric. Yeah, okay. You should get this now. So now you create a group, right click on unnamed.
Yeah.
Give it a name. Just right click on shape 2D view.
Which one?
The shape 2D view. The second item.
Rename it?
No. You need to end the transform function because you see those little arrows over there, the red, green, blue arrows. You're in the transform mode, which means it's expecting you to move and rotate this object.
Okay.
So right click over here. Yeah.
Yep.
Context click, and you should get a menu that says transform or something. Or just press the escape key right now.
Just hit escape? Oh, there we go. Okay.
Yeah, here you go. Okay, that's better. Yeah.
And this
so
is
now
what I want.
You can go back. Yeah. So now you can go to the template and copy the ref and value items and paste it here.
Right.
Yeah. Okay, you're in the sketch mode. So go to task over here. Yeah.
Is there something I need to do to be able to copy it?
Yeah, just do right click and copy. Both of them at the same time.
Seems to
Or
be
you can just
disabled.
can just do edit copy.
Or you can click on the button on the toolbar.
Next to the scissor.
But it's disabled right now.
Yeah, it
No,
apparently is, but it works.
Oh, it still
yeah,
works?
it looks disabled.
Yeah. Just to edit copy, that's the fastest. Okay,
So,
over here, go to, hang on, don't do anything. Just go to task first, because you're in the edit the sketch mode. You're in the sketcher mode. So next to your model, in the combo view is the task tab. Next to the model. You see the combo view where below that. Yeah, next, you see the tasks. Go to task. Yeah, close this.
Oh, okay.
Now we can paste the stuff you were trying to paste.
Okay.
Copy and paste. Yeah, paste over here.
Okay.
There you go. And now you select the group and export it. Whatever.
You have to rename the thing first.
So I need to rename this, right?
Yeah.
To fsilk 016.
F2.
Or it's advisable to just click on the template and hit F2, so that you'll go in the edit mode, and then you can copy the hit F2.
Copy.
And copy the text. Yeah. And here
Paste.
also,
Yeah.
All right.
Okay, now
I can then export this.
Yeah.
Mm-hmm. There's a step up icon to do that.
So I did the
yeah, that's so.
And then now I have that in here, so I should be able to open it up.
Or you can just import directly into FreeCAD directly, and then you should see.
Look at that.
Open a new window, a new file.
Oh, yeah, I gotta share my KiCad now. Yeah, so I do see it now. So I must have just been naming it incorrectly or something.
Likely.
So yeah, this is better than what I was seeing. Yeah, I wasn't seeing it before. So I think I must have just been naming it wrong.
That's progress.
Yeah, thank you. I think I probably didn't have it named correctly. The copy and pasting the name worked much better.
All right, awesome. So any more questions, anyone? Want to wrap it up for today? All right, looks like that's a yes. So if we plan to do this again next week for sure. So if there are any suggestions on what we should cover, let us know and we can do that. Or I'll come up with some topic on my own of what to do. Today we covered on how to do local libraries for schematics. Next time around I can show how to do that for footprints, for example.
Thank you so much, guys.
All right, see you guys. Awesome. Thanks a lot.
Thank you.
Thank you.
Thank you. Bye.